hang that up right there. And the focus off? Probably. It's probably focused on that stupid bright spot up on the door. Anybody that tells you that iPhone cameras are good to use for, or that phone cameras in general, anybody that tells you that phone cameras in general are good to use for this stuff, they're full of crap. Anyways, welcome to tonight's live stream, everybody. So, again, same situation. Video shot on a cell phone because my computer took a massive dump on me. Yay! So, tonight's objective is to try and get some of this circuitry working. I've been trying to program the ADTiny with, I guess I haven't explained what an ADTiny is. But I've been trying to program an ADTiny chip with this. This gadget is supposed to be specifically for programming the ADTiny. What if I tell it to focus right there? Oh, it won't let me because it's front-facing camera. Anyways, and this thing has not been working. So that is disappointing to say the least. But there's like an old-fashioned way where you take an Arduino and you plug it in. Let's start tonight's broadcast with our brew of choice today. And hopefully you guys are having a good day. My day was interesting. Not completely terrible, but interesting for sure. I'm a little curious to see. One thing I noticed on the last live stream is that there was a lot more people that popped onto the live stream. And I'm curious as to whether that was because YouTube promotes cell phone-based live streams more. I'm wondering if that's the case. It's certainly possible. I don't know. But it just seemed odd because I've never had that much participation in a live stream before, so I thought, well, maybe not. I don't know. So anyways, cheers to a good live stream tonight. And if everybody could let me know that the audio is actually working this time, I'd appreciate it. I'm doing something a little different. I have a Rode mic, Rode Wireless Go mic plugged in, hoping to improve the audio quality, at least a little bit. So if anybody could tell me, works perfect. Thank you, babe. All right. So I figured we could at least try and improve something of this. So here's what I want to accomplish tonight. I have to make the Triac. We're got to make the Triac work. And with the Opto Isolator. We don't really have any reason why we can't. However, the easiest way around this, I believe, is going to be using the Arduino Uno to deliver a signal. So we're going to use the Arduino Uno to deliver a signal to our Nano. All right, I know this gets a little wonky, but so our Nano, I believe, has a program, and I'm going to try to confirm this here. Because the last time I used my Arduino Nano was to... I can't do two things at once because I'm terrible at this. So the last time I used the Arduino Nano was to actually reproduce this control mechanism on this chip. So I should be able to do the same thing on this mechanism. Should be able to do the same thing on this mechanism. I just need to make... I'm curious. I want to get the pins right. So the biggest thing is I don't know which pins I used And I'm thinking I can find that out by looking up the code that I used before. Now, this is going to get a little more interesting. I wish I could show you guys this, but like I said, my computer kind of took a dump, so I'm actually using my work laptop. Here's something interesting that I've been doing. Let's see. I want to go up through here. Here we go. Something I if you would work correctly, it would be helpful. So something I discovered interesting when you're working on projects with that sounds like a plan. It's a 7-pin, pin 5 input, output, pin 3 PP4. Okay, that's for the ADTiny. I was working on developing the program that right now is in the Arduino Nano for the ADTiny, which is a different pin format. So what I want to find is, what I'm looking for is a copy of the code that I would have put in the Nano, because I want the pins that I used. If I can get the pins that I used, I should be able to duplicate the project that I did before. All right, is this it? I believe this is it. All right, 0 cross input was on pin 2, and PWM input on pin 4. Certainly, here's the example. Can you please write C code? Okay, found it. Found my code. So now I should be able to duplicate the pins. And here's what this generally amounts to. I need to make an Arduino Nano, send a PWM signal over to, an Arduino Uno, send a PWM signal over to a Nano, and then that Nano is going to use the interrupt signal to drive the opto-isolator. That should work. It's a couple steps. There's a couple steps in here. Yes. So let's get on with this. I need to drive... Alright, output pin to drive load is pin 9, so we need to take a jumper from pin 9. Pin 9, right here. That jumper's not big enough. We're going to use this wire. So we're going to take a jumper from pin 9 over to here. Okay, and I already have a resistor. So an opto-isolator, yes, an opto-isolator is an LED. LEDs are not loads. They're diodes. And I believe that makes them a passive component. So because they're not a load, you have to add a resistor in line to limit the current, because they will not limit the current themselves. All right, so we have a resistor in line here, and I can take that back to ground. Which side of this am I using? 5 volts, and the ground is the red. It's odd the way that jumper doesn't work. I can do this one. So then we take this pin back to ground. That was a little loose. I guess they're a little bit loose. Okay, that should complete that. I need to make a ground for the Arduino right here. Okay. I need to add 5 volts to the Arduino. That's not a jumper. We can use this one. 5 volts right there. Should I go volt in or 5 volts? I'm going to go volt in. Okay. Is this... I believe this is my power for this here. Just let me double check this. Yep, it's plugged in. Okay, so I'm just going to double check that this thing turns on. Yep, we do. And we got power. Ta-da! Okay. Now, alright, that completes power ground to that. That completes power to that and ground to that. Now, I need to go to pin 2 is a 0 cross detect. Okay. So on this, I need to connect. Make sure I don't have any stuff over here. I need to vacuum up. That coffee coffee boiler we took apart the other day. Oh shoot. Now I forget which one's which on this. I'm gonna have to look that up. Uh-oh. You know what? I got the laptop right over here. We can open up another tab and look up 4N25, right? 4N25 pin out. 4N25 data sheet. .4N25 semiconductor DigiKey. DigiKey is a great resource when you're looking this stuff up. And we go to data sheet for 4N25, and we are looking at E is the output. So that's pin 4. All right, that's green. So green is the output. And we want the output to go to... Don't get carried away. I need my jumpers. That'll work. It's the wrong color. I have lots of jumpers here. Just pick one. Too many jumpers. Does work. And we got a green jumper. All right. So this should go to the ZCD pin, which is pin 2. Zero cross detect, pin 2. Right here. All right. So that's a zero cross detect pin. Good. Now, let's see. I need... to power it. Oh, right. I forgot how this worked. Okay, so I'm going to give it power on this pin, right? That's going to bridge over to here. Okay, so this is ground. And... oh, buggers. I hate it when I forget stuff. Especially when I'm a bunch of medication and some alcohol deep and trying to figure this one out. Okay, so I got power going in right here. That's going to be resistor and then switched ground. All right, so I want... why is this not coming to me? All right, this is driving me bonkers. I should have wrote this down. I should have wrote this down. Oh, man. I might actually have to draw it out. All right, it's all revolving around that switch. So that switch goes to there. That makes ground. So green is ground, right? And then orange is going to be signal. Okay. We're getting it. Orange is going to be signal. That is going to switch. Every time it detects 0, it's going to turn that on. It's going to ground, so it's going to go low. Okay. That's what we're doing. Because that's how you do a pull up or pull down style system. Perfect. Right? Yes. Okay. So this goes to ground. This goes to pin 2, D2. And this goes to 5 volts. Ta-da! Alright, cool. That side is done. Now, pin 4. I want a different color for that. Blue? No, I have blue. I have a red. Eh. Purple? That's not double-sided. White. We got a white. All right. Pin 4. Shucks. Is it D4 or A4? Oh, it's a good question. D4 or A4? I'm going to go with D4. Okay, now that should be the program for this. And that should be the end of this. Okay. All right. Now, realistically, I could do diode test function on the end of the DIAC, or the opto isolator. I could do diode test on that to confirm whether or not that's actually opening and closing. Or I can apply a voltage. Do I want to jump straight? There's no reason I can't jump straight to line voltage. I have my box here to do that. Let me get the Uno set up. All right, so if I go up, I haven't said what I'm doing over here on the laptop. So one of the things I discovered a few months ago, which had me really, I found a bit. Nice. Thought I was missing that sucker. Anyways, a few months ago I found out that you can use ChatGPT to write code for you, like write C# code for you. And this may not come as a surprise to many, but I'm a bit of a pessimist, and I thought, I don't know, is it worth it? Is it work? It works. It definitely works. It's not perfect, but it does work. You essentially have to be very specific with what you want the code to do, and then ChatGPT is able to take your specific description and turn it into a C# code. How do I know that? Because I tested it. This code, it worked. The last driver, the one I was driving this on, worked great. Ooh, nuts. I got nuts. I can put nuts on stuff. In fact, I probably should put my nuts on stuff so I don't lose them. Put my nuts on studs. Anyways. Alright. That's what I'm doing over here. Since my computer crashed, I had all my codes that were written for these Arduinos. I had them stored on the computer. Computer crashed. The codes, I believe, are still stored in the hard drives, which I'm hoping maybe I can do a motherboard and save. That's what he said. Absolutely. But for now, I have no access to the codes, so I'm actually going through my chat history in ChatGPT to find copies of the original code that was written that should still exist on these. So that's what I'm doing over here on the thing here. Okay. Integer float. How do I declare a variable for Arduino? Unassigned time intervals, delay microseconds. This may not work. I may not actually find the one that's in the Arduino, which would be unfortunate. However, it's not so unfortunate it can't be rewritten. The thing is with the code... Wait, constant PWM input PWM input pin in the Arduino code. Read PWM, connect PWM signal. Nope. I need this to have a... Alright, so we got a TRIAC. ZCD pin. Nope, that's still 0 cross. I think I'm coming up blank on the original code that was written for this. And the only reason that matters is because I don't know what pins were used in the creation of the code for this. What I need to do is I need to set a potentiometer. I need to set it to read a potentiometer and adjust a PWM output based on that potentiometer. That PWM output can go to this, and then it should function. I know I did this. I actually posted a picture a while back. So let's see if we can recreate this. It's actually not that difficult to download a program, assuming I have the right cable at hand. I should, because I had the cables for... Oh, bonkers. This is about to get out of hand. I had the cables for doing this. Alright, we got mini DVI. What I need is I need a USB B to A is what I need for this. Ah! Nope, that's definitely not it. Ooh, what's this? Hey, another C to Apple. That's cool. Do. Okay. I know I've got one around here somewhere. Let's see what chat... Let's see. I need... Oh, that just made a mess. Yay. We love iron filing messes. Don't look in there. It's a mess. Don't look in there. So I'm sure I've got the proper adapter, because all my cables that I had when the computer blew up, I put over here, quickly stashing things, and found it. Ta-da! Alright, this is all I need. So, what I'm going to do... You can do it! Ha! Thanks, Anu! You can do it! Yep. Plug this in. Cool. Now, what I'm going to do is I'm going to have ChatGPT over here write another code for me to, it's actually, this one is very easy. Very easy. Writing another Arduino code for me. Alright, so all I needed to do is read a potentiometer. Of course, I'd be happy to help. What specific function would you like the Arduino code to implement? They try to put so many manners into ChatGPT. It's kind of funny. Oh, I need an air conditioner for this room. Something fierce. Please provide details. Okay, I would like my Arduino Uno to read a potentiometer. I'm not going to spell this right. Yometer. Yeah, told you. Spell check. Get out of here. To read a potentiometer and adjust a PWM output based on that potentiometer from 0 to 100%. Do. This really should be quite easy. All right, so not only does ChatGPT write you the code, it will actually tell you how to wire your system in a very basic manner. It'll tell you how to wire up your system for said code. All right. Now, I'm going to look over the code. Being it's so simple, the chance of there being an error is actually pretty low, but not impossible. So, we have constant integer pot pin equals 0. All right, so we need a potentiometer pin going into A0. Let me just go ahead and get that started. I'm going to go with another white. Okay, so that's A0. I'm going to place a potentiometer right here on my little breadboard. And the middle pin on the potentiometer is the pot pin, or the variable pin. All right, so that takes care of that pot pin. Now I need to give it power and ground. Not that one. We got ground here. It's kind of a short ground. I think they're all kind of short grounds, though. Was this my twinning one? No. No, it's not. I think where I'm going to start with this, while I'm brainstorming here, while I'm connecting these pins, I think I'm going to start... All right, ground. Okay. And power. That's short. Need longer. That'll work. Volt in. Ooh, that is... Do these? It'll be alright. Okay. Double check. Do we have power? We got power. Sweet. Okay. Alright. Now I need to give the potentiometer a power and a ground. So I'm going to take one pin to ground on that one, and I can use a short one for this. One pin to power. I think I missed this pin. Yep. There we go. Fixed it. All right. Now I have a potentiometer input to the Arduino Uno, which should regulate a PWM. PWM output pin is going to be pin 9, which is over here. So that's what I want this connected to. Now, an unspoken thing. Hi, Mikey! I am attempting to build a driver circuit for induction motors. Well, actually, in this case, it's a heater, but kind of the same thing. So it's an AC motor controller, essentially, or an AC driver circuit. I actually have one right here. This is your super basic. What I'm doing in a nutshell is taking this, which is your super basic Amazon, like $10 AC induction motor dimmer switch. So like an AC dimmer switch. So like when you put a switch in your wall outlet, right, or on your wall for a light, and it has that little slide on there that does the dimmer function. It's basically this. There's what's called a triac in there, and then in this case they're using what's called a diac and some capacitors and varying some mechanical functions to make the triac switch the AC current on and off quickly. So it's AC version of PWM. I'm doing this with a microcontroller because I want to do it in a smart way. That's what we're working on. All right. So I've got my PWM, my potentiometer. Oh, the unspoken thing that I'm working with here. If anybody's familiar with Arduinos, then you're probably going to look at this and say, why are you using two Arduinos? Arduino, even the most basic Arduino, is capable of running both the switching function of a zero cross circuit. I know I'm using technical terms, but it's kind of hard to get around the technical terms here. So Arduinos are capable of running, like they're fast enough to run the program in a manner that allows it to interrupt and keep going. What does that mean? This piece right here is the circuit that we were developing earlier, and this circuit detects when the AC sine wave hits 0. Only this does it in a manner that allows us to lead. We can tell this thing that we're at 0 before we actually get to 0. So we can lead the whole mechanism. And that's important for timing purposes. So this thing has to tell the controller when that 0 point is on the sine wave, when we cross 0. Because the computer needs to count milliseconds after that. So every time the 0 counter goes, hey, we're at 0, then the computer goes, oh, we're at 0, now I'm going to count 1, 2, 3, 4 milliseconds, and then I'm going to turn on. That gives me approximately a 50% duty cycle on an AC sine wave. In America, we're at 60 hertz, so that's 120 pulses per second. That's 8.25 milliseconds per pulse. So if I tell the circuit, if I tell the computer that, hey, we're at 0, and then the computer counts 1, 2, 3, 4, and then turns on, that means we have turned on the switch at halfway through that pulse, which gives it essentially a 50% duty cycle. I'm using generic numbers, but that's the idea. So that's what we're doing here. And the whole reason I want to use microcontrollers to do that job is because the same reason I'm using two controllers. When the Arduino sits there and goes, the Arduino has all the other functions to do. It's got to run a screen, it's got a lot of other things to do. And the interrupt circuit that allows it to do the countdown for the driver stops all the other functions from running. So whilst it does work, it's not the smoothest. So I found that the best way to do it is to have one dedicated microprocessor running the actual driver, while the other microprocessor runs all the other things, like the display screen and the potentiometer inputs and outputs and sensors and shenanigans. I wish I had friends like you in my life. Damn, dude, that's deep. Sorry, my screen's a little bit small. I'm sure Mimosa, I'm sure you've got plenty of friends. I don't actually have that many friends. But anyways, I can be somewhat difficult. I'm a bit of a difficult friend, I'm not going to lie. Anyways, all right, so I'm going to take this program now that we just created in ChatGPT. Haha, my bad. I didn't mean to make it sound sad. Maybe it's just the alcohol talking that I made it sad all for you. Sorry. Anyways. All right, so at this point, I'm going to take the code that we got ChatGPT to write, and we are going to shove it into this here Arduino Uno. So now I can open, what I can do is, this is super easy. If you want to use ChatGPT to write your codes, I actually recommend it because it's super easy. Literally, it pops up the screen, like it writes the code for you, and then it gives you an option to copy. So you just copy the code. Then you go into your Arduino IDE, which Arduino IDE is the what does that stand for? It's the program that takes what you want and turns it into the ones and zeros that the computer understands. All right, I need to select a board. This is the first time I've hooked anything up to this. All right, so board, Arduino Uno. All right, and it should be on port. All right, COM3. Good. Arduino Uno. Good. All right, we're going to erase everything that's already here. And I'm going to paste the code in. We're going to check it. Verify that it works. Compiling sketch. Sketch uses 1,314 bytes, 14%, and it looks good. Okay. 0 to 1 to 0 to 255, some percent duty cycle, potentiometer value. All right, so it's mapping. Okay. This should work. Now, I'm going to use my oscilloscope, my battery-powered oscilloscope, which has a complete shit battery. Upload. Yeah, we uploaded it, right? Compiling sketch, done compiling. Uploading, done uploading. Done. Sweet. It's literally that simple. I love it a lot. Okay. Now the code is in the Arduino, so we're going to hook up our power and our ground again. Okay, then our potentiometer goes into A0 for analog input, right? And then our PWM output goes to digital 9 output. Now, that should work. Yes. Let me just think about this before we blow anything up. So I am not going to hook up my 110 volts yet. I'm going to turn on my oscilloscope. We have our leads here. I can do more leads. Where's my other leads? Excuse me. Got the hiccups? 3 sheets to the wind already. Oh, I must have put the leads in the multimeter. All right. We're going to hook up all, I guess it's not all of the leads, but at least 3 channels worth. Okay. Again, I apologize. If I had my normal live streaming stuff working, I would be able to put this on the screen. But, you know, sometimes you just can't help it. Did you guys hear that? How do you like that? The oscilloscope runs on Windows 95. I hope everybody out there is having as fun a time as I am. It's Leedy. He made a joke because the leads. Ha! That's a funny joke. I like it. All right. I am going to connect to this here negative. That's my negative lead. Okay. And then we're going to, this is going to be channel 1. All right. What do I want to do with channel 1? I think I want to read the PWM coming out of going into the Uno. So I want to read the PWM signal. I think I want to do that. And then I definitely want to, with channel 2, all right, scanner scope, lab scope, 4-channel lab scope, Doo-ba-doo-ba-doo-ba-doo-doo-doo. Okay. I've got some other things I can set up in there. All right, for channel 2, I definitely want to register our pulse to the controller. That's fair, right? What's up, Blackjus? Is that how you say it? Blackjus? How you guys doing? I hope you guys are having a great night. We are doing some fun it's fun for me at least. For sure. And I really hope all this stuff works, because if it doesn't, I got to go back to the drawing board. Traces. So far I'm at 2. This should be good enough, right? Oh, yes, I need to change the traces because we're only doing 5 volts, and they're set to 400 volts, so 5 volts. Trigger is out of range. You know what? Make it 10 volts. Okay. And back. Trace 2. Make that 10 volts. Back. And let's do trace 3. Display. Just because I have it plugged in. We're going to go with that 10 volts. Back. Back. Okay, back. Trigger. We're going to take the trigger down to... There we go. Now the trigger's in range. Back. And we have some really funky readings. Why do we have funky readings on those traces already? That is odd. Alright, so when I turn power on... Do I have it hooked up backwards? Alright, let me take 3 out of here and bring up 2. Did I hook up something wrong? Ground goes to ground. I did. Dummy. That's positive. This is ground. Okay, now we are all over the place. Why are we all over the place? A little bit. We're not stable. I wish I could show you guys what I'm seeing. I really do. Yo! Unfortunately, this is what we got. Alright, now let's see. I've got trace 1 is yellow, and that is on the PWM coming off of this. Ahaha. There we go. Perfect. Alright, so the trace is working. So the PWM program is definitely working. What I don't see happening is... What I do not see happening is the nano 9 D9. There is no A9. All right. What is that doing? That is staying at 0. So I do not have a power coming into... Yeah, I do not have an input coming into the triac. Okay. Is it because my resistor's too much? No, it should be a 220 ohm resistor. That should be fine. What if I take it off and put it on that way? Nope, still nothing. Alright, so it's not that. Could it be that the nano is not programmed? We have power. Okay. Okay. And, alright, so I got power, and the only thing that needs is to read. What if I need to go back? Oh, dang it. It locked me out. Oh, here we go. I need to go back to that. Yeah, I need to go back to that one program and see. It may be... I may be getting... I may be on the wrong pin. 7, 4, and 5. So pin 7 can be the interrupt signal from 0 cross detect 5 pin. Did I go too far? Here's an example that incorporates your requirements. 500 hertz. C# code that uses PWM signal of 500 hertz. What is my frequency on channel 1? Oh, you're not going to tell me, huh? Can I engage? Let's see. There. 500 hertz. Yep. All right. So we're at 500 hertz. Yes. PWM pin 4 is the PWM input pin, but that's pin 4. That doesn't mean that it's D4. It could be A4. Let's try that. Let's try A4. Well, something happened. Something... Oh! I don't even have it connected. Good grief. No, don't. Why are you being weird? Alright, so I still don't have... My connections are not very good on this. I'm finding that out for sure. It looks like my Nano is still not doing its job. I wonder if I need to reprogram the Nano. Alright, I got power. Try a reset. Nope. It's still not doing anything. Alright, so at this point, I'm pretty sure I need to reprogram the Nano. My Uno is definitely working correctly. And my Nano is not doing anything. So, I'm going to look for that cable to be able to reprogram the Nano. Having the copy pulled up here makes it a lot easier. Oh, another cable. That was the same cable as last time, genius. I know I've got some stuff over here. I have far too many cables. I have a lot of cables because it turns out, even though a cable will mark itself blue and advertise that it is USB 3 or 3.1 or 3.2, doesn't mean jack diddly. Because they do not always hold to what they tell you. Oh, good grief. I know I have a few different mechanisms that I keep saving to program. Here we go. That'll work. Okay. For this time, I am going to have to take the Nano off. That's going to be the easiest way to do this. Maybe. It is not the easiest thing to get off. Breadboards are great until they're not. Okay. Now, I plug in the Nano. I plug the Nano into our computer. And what I'm going to do is I'm going to copy this code. Zero cross detect. Oh! I forgot to hook up the zero cross detect. I'm a genius. We're going to program it anyways. Copy the code. Now, I need to switch the board. It is no longer an Arduino Uno. It is now an Arduino Nano. It is on the same port COM3. Why does it say COM4? Alright, whatever. We are now going to erase everything that's already here and paste that and send it. Done compiling, uploading. This one uses 3,000 bytes, but that's because it has an interrupt circuit. Eureka! Light bulb! Still uploading. Still uploading. What do you think, guys? Should we go to drink number 2 for tonight? How long has this been? 53 minutes. Still up. Why are you taking so long to upload? This thing's going to error out on me. You dirty bastard. Still uploading. Come on. Should have left it on COM3. Okay, so one thing I need to do, I wasn't giving it a zero cross signal, which is why it wasn't turning on. Because I'm a genius. Okay. This can go back to here. Yep. Channel 2 can go back onto that. Why are you constantly trying to lift the thing up? Pain in the butt. You know what? I got you. I got you. Make sure that's in, and then we'll just connect to that. Ta-da! Easy enough. Oh, programmer is not responding. Attempt. Yep. I think I'm on the wrong COM port. Well, that's what it's... Oh, good grief. This is special. Why? Programmer. What if I try... Oh, what if I try the old bootloader? I do kind of remember something about that. Most of my Arduinos are pretty old, so maybe I need the old bootloader. Maybe some snacks. Hydration. Yeah, that wouldn't be a bad idea. Hydration would not be a bad idea. Alright, so let's try this again with the old bootloader. Done compiling. You busy thinking about stuff over here? Oh, I think it's in. Are we in? Let's try it one more time. Because apparently I was looking away. Done compiling. Oh, dummy. I was hitting the wrong button. Upload. Uploading. Done uploading. Nice. It takes the old bootloader. Okay. So that takes care of that. Put this back on. Okay. All right. We got our power and ground, which apparently I used the same color for because I'm a genius. All right. Now the slightly more controversial part. I'm going to I need to plug this in. Okay. And I need to give this an AC signal so that the interrupt circuit actually works. Alright. Now the last time I switched on this box, it went kapoof. This box right here. It went sploof. And I got a picture of it happening. Alright. Now. Always slightly more nervous when you have line voltage running in your project. Okay. Now, this line voltage should not actually do anything. We're just sensing it at this point. But what I should get is my 5 volts on... Alright, I got my PWM on channel 1. Just be safe. I'm always safe. Alright, so I've got my PWM signal, and that's off because I should not be getting a trigger signal yet. Let's turn this on. My fuses are set. Nothing. Nothing. Dang it. Okay, what am I missing? I should be reading that. I'm reading that. I should be. Alright, so I can take channel 3 right here. I should be reading a signal from the zero cross detect. It does not appear to be reading a signal from the zero cross detect. Why not? Alright. Now I need to move on to debugging my zero cross signal. Okay, for this, now I'm going to need a different meter, or I disconnect all these things and rehook up to the line side of that. Do I have leads from my other multimeter? Available. I do not. Yeah, I do not. And I need to be careful with this. This part I definitely need to be careful with. Okay. Could something be loose? Something could definitely be loose. 100%. But the first thing I need to do is confirm that I have a 110 volt sine wave. Oh man, I wish I had a signal generator right now. Shucks. If I had a signal generator, I could just feed the zero cross detector with like a low voltage. Well, actually, no, I can't because. No, if I had a signal generator, I could feed a 60 hertz sine wave. No, I could just feed a 60 hertz square wave into that, and it would give me a generic timing. I don't have a signal generator. Buggers. Tried building a signal generator at one time. It went kaputs. Okay. What am I going to do? What I need to do is I need to disconnect. Alright, I can use this, but I need to adjust everything, disconnect, and start at this slowly. So before I do that, let me confirm that that is indeed getting the 5 volts. Alright, 5 volts goes to there, and then it drops. No. It would appear that that is stuck at 0. Yep, I'm on the power side. So that means... Alright, I'm going to turn off the 110 volt. And I'm going to move that out of the way. And I'm going to read this. Still stuck at 0. And that side is 5. So that would mean... That would mean my opto-isolator is stuck on. Unless... is... pin 3 grounding it out. Nope. Disconnect ground. And I got 5 volts. Well, that's not cool. Alright. I may have a bad opto-isolator. Let me just double check all this. So... this runs to here, and it goes to power there. Oh, why does it do that? I think I did this backwards. I think I had this time to make a list. Heh. I think I may have had this backwards. So I think I may need to power this side. Yeah, because if I power this side, then it's running straight to ground, which means this side is always going to be ground. Yeah, so if I power this side, that goes to there. This should be ground. But that doesn't make any sense. Why did I do it this way? Why did I do it this way? I messed up somewhere in here. I'm sure of it. Yeah, because I should have tied this to here. Do I need to remake this? Yeah, I should have tied this to here so that it powers this, and then this grounds that pin, and it can't go through there. So when this is open, I did it wrong. Probably tired. I think, Mimosa, I think you are correct. But, nothing we can't solve here. Let's do some quick fixing. If I can do some quick fixing. Do I have my... What'd I do at my, Oh, it's right here. It's right here. Okay. Alright. Let's see if I can do some quick solder fixing. Okay. We're going to move this up here. That's going to start heating. 300. 330. Alright. We're going to do some solder sucking. Let's get my solder out. And where's my tip tenor? I don't know where my tip tenor is. There it is. Wow, is that it? Whew! This thing's at 330 already. She's a quick. Ouch. Okie dokie. Yes, so I do believe that I have this connected incorrectly. Do some solder sucking. Oh, nice. That was pretty clean. Now, if I attach my power to... I had some tweezers over here. Here they are. So if I attach my power to here instead of there, that means I'll power this pin until this turns on and grounds it. Yes, and it will pull to ground because this resistor will prevent current. Ta-da! That should do it. I do not know why I messed that up in the first place. Alright, that should do it. Good. I'm going to put this over here. Let that cool down for a little bit. By golly, we just may get this. I am gone, though. Night. Have fun. Night, Mimosa. Thank you for stopping by. And, Anu, thank you for stopping by. I appreciate it. Okay. Very much appreciate it. I absolutely love it when people actually, you know, participate. Makes everything more enjoyable. Okay. Now, I should be able to power the resistor. Provide a ground and signal. Oh, no, okay, good. I can't let Can't let that thing go to sleep too fast. Okay, this needs to go over there. And now we should have 5. All right, engage that. And I should have 5 volts. 5 volts. Ground. Perfect. That's what it should be. Okay. Now, I already know this is working correctly. And that's working correctly. Okay. So now I should be able to apply power to get that. And then that should be on. Okay, this channel. You know what? I'm going to go ahead and try to read that. Can I read that? Can I get around there? I don't think I can get around there. I'll have to read it at this end. All right. Now, it's doing something. Not a whole lot of something, but it's doing something. Unfortunately, that should be dropping all the way down to ground, and it's not. Why is it not dropping all the way down to ground? Is the resistor too low? I almost think the resistor's too low. What if I adjust it? Oh, good God, that could have been bad. Yeah, that is not dropping it all the way down. Why not? Now I need to figure out why this isn't dropping. I have the signal input. It is actually doing a signal. It's resisting you. I knew! Ha! You said you were going to bed, and you're still coming up with jokes. Oh, man. So what's happening is I'm averaging about 4 volts and then blipping down to a lower voltage like 3.5 volts or 3.75 volts. It is dropping down and showing me that it's registering the zero cross detection, but I'm not dropping the whole way down. So either the opto isolator is not turning off completely, or now it is. No, that's a 4N25. That's a transistor-based opto isolator. So it's got to be the resistor, right? Another wire to Mimosa. I bid farewell. I won't rest for many more hours. Oh, man. It sucks when you can't fall asleep very well. It's only 9:19. Oh, geez, let me think about this. I've been over this. I've done this before. Why? It's almost like my resistor is not enough. What resistor do I have in there? What can I do to add more resistance? Oh, I can add resistance. I have a 1K resistor right here. What happens if I add 1K resistance to that circuit? So what I can do is take a resistor here and just put it over to tiny wires are not my friend. And then, oh, that's much better. That's much better, but it's still not enough. Yep, we're almost up to a full 5 volts, and we're almost dropping to there, so it's just not enough. What do I got here that's just laying out? 47,000, 68,000, 1,000. Do I have a 10K ohm? I'll bet you I do. Question is, do I have a 10K ohm? There's 100, 10, 51. Oh. There's my 10Ks. All right. So I'm going to put a 10K in here. And since this is an unloaded circuit, there's a high possibility that the 10K will be enough. Okay. Oh, so close. So close. Why is that fighting me so much? Alright, let's try the 68K. I won't rest for... Maybe it is the resistor. Retrace steps and see alternatives. You are correct. Right now we are troubleshooting with multiple resistors. Basically, my idea is that... But no cigar. Yeah, right? Close but no cigar. My idea is that the opto isolator is acting like a switched ground. The resistor is supposed to create a barrier of current so that when the ground completes, the positive side of the switch drops to 0. That's the idea. And I'm not getting that. Because my resistance through the switch is still enough to leave. I wonder if there's a better way to do that. Oh, I've got diminishing returns here. I almost need like a 1 million ohm resistor for this. Which I do have 1 million ohm resistors. Let me think. It's on the ground side. Is there a way to do it on the positive side? Is there a way to place... switched on the positive side? Yes. There is a way to do the switch on the positive side. If I put the resistor on the ground and then put the sensor on that same ground, yes, then now let me get this straight, when it would complete, when the IGBT turns on, it would allow 5 volts to go to the pin, and then when it opened, there shouldn't be any back because it's a transistor, so there shouldn't be any backflow, so it should go straight to ground, regardless of resistor. It should cut power off clean. That is a way I can do that. That might be a better way than this whole resistor business. But let me try one more resistor. I'll see if I can find one of my 1 million ohm resistors. Well, there's a 3 million ohm resistor right there. 220,000. I'm just not sure I'm actually going to accomplish it with resistor on the positive side, because we always have resistance through the switch. Well, that's a 10 million ohm. 2,000. 200. 100. 300. 1 million ohm right there. Honestly, never thought I would ever use the 1 million ohm, or like the million. Certainly will never use the 10 million ohm resistors. But I really want to see what a 1 million ohm resistor will do in this instance. Oh, now I'm making a mess of my resistors. Dang it. Set that to the side. I need to clean that up. Pick up the 2 resistors that I dropped, because I'm a klutz. Alright, here it is. 1 million ohm resistor. Do what you gotta do and learn as much as you can from it. You are 100% correct. Oh, snap! That is so close to being it. It's ridiculous. Okay, the problem here is now I'm only at like 4.5 volts on the top end. Now that shouldn't matter, because I can still run, you can make a reason to use it in the future. The 4.5 volts on the top end should not matter. The fact that I am not clearing 0 volts is a bit of struggle right here. Why am I not clearing 0 volts? I'm not clearing 0 volts because no matter how much resistance I add to this thing, it's going to have a tiny bit of current. Right. I think the better way is to switch around. I think the better way is to switch around that switch. Thing is, though, that should be enough to turn on this program. Yeah, and it's not turning on that at all. It's not pulsing that. Okay. A4, let's move this to D4, because I'm not sure I'm in the right pocket. That's not making a difference. Let's move the input to... Nope, that one's pretty clear. That one needs to be on D2 for sure. Oh! Oh! Yeah, I just took that off. Ha ha! It's running! Let's pull that down. Give that a little bit of distance. It's running! Yes, sir, it is! Come on, click on there. It's running! Oh my god, I love it. Somehow it doesn't seem to be in sync. Oh, these connections are terrible. Oh my god, it's working. Hell yeah. And if I'm not mistaken, this thing is doing exactly what I wanted it to with the whole adjustable trim. I think I'm going to need more accurate measurements to be sure. But I think, because this thing's kind of all over the place right now, but I'm pretty sure it's working. You seem to know your stuff. What's your Cori status? Misty, I have no idea what a Cori status is. I don't know. If you wouldn't mind expanding on that, I'm curious. All right. Either way, we now have a pulse. Okay, so at this point, I am pulsing to the opto isolator. Now I need, at this point now, I need to reset. Okay. I am getting the trigger off the zero cross detect. That's running into the Arduino. I am able to adjust the pulse width based on the two programs. Perfect. Oh, you are dragging the voltage down. So every time this turns on, it's dragging the voltage for that. I think my zero cross detect circuit, it would be better with a switched power. I'm thinking it would be better with a switched power. Because that way I can actually have a small resistance between ground and then I just have a current limiting resistance between ground and signal. If I'm switching the power to there, there's no way that's going to backfeed. No, because it's optically switched, so it's not going to backfeed. It's not going to get a parasitic drain through the gate. So it should be able to turn clean off to a clean zero. But this is working even though we don't have a clean zero, so I'm okay with that. It looks like, so every time that we turn on from this, oh, probably because we don't have much of a resistance to the LED, so it's probably drawing down the entire current. In fact, if I read, where's my third? Here we go. I can use my third string to actually read the positive volts. Yeah. I'm actually I'm pulling down the current on my power supply is what I'm doing. So I need to increase the resistance to the opto isolator. Yes. I need to increase the resistance to my opto isolator so I'm not pulling down the current on the rest of the machine. Because what's happening is I'm pulling down the current on the rest on my power supply, which is affecting switch. It's not making that big of a difference. It's just something I gotta do. Okay. Now, what will really make the difference is when I add a sine wave to this. That's what will really make a difference. And for that, can I detect... Oh, I wish I had a signal generator. Wait! Maybe I can pull voltage off of this thing. No, that's on the DC side. Maybe I can add some pins to the AC side, because this thing only runs 8 volts. It takes the 120 down to 8 volts. I like that idea. Pull the voltage off the backside of that. It's not going to be too much current. I have to make sure, because it's only a 3,000 watt. I like that idea, though. That needs to be separate, though. Yeah, so I need a separate meter on that. I can use my Tektronix meter. Yes. I can use my Tektronix meter to measure that output. But I'd prefer not to do it at a full 120 volts. So I'm going to reset all this. But at this point, this live stream has been pretty long. What do you guys think? Should I cancel the live stream and come back, or should we continue working on this thing? So I think what I can do now is actually, I need to pull up the pin out for that. Fuck it, I'm just going to keep working on it. All right. We are getting somewhere. $10, $17. I need... Alright, I'm going to remove this. So we're going to take the dangerous voltage away. Put that over here. Bunch of stuff dropping. That doesn't matter. Turn this off. I need a bigger resistor on there. What is that resistance? Shucks. I have a 10k ohm resistor right here. I'll put the 10k ohm in there. Now I should probably do a 1k. Because I think that's only a 220 ohm resistor. Keep it up. Okay. Anu says keep it up. So we're keeping it up. Brown, black, red. I could have sworn I had a... That's a 1k. That's brown, black, orange. Which makes sense. $68 is blue, gray, orange. That's blue, gray, orange. So that's a 68. 1 million. That's 10k. Okay. All right. 1k. That should limit the current better. So I'm going to take this 220 out. I'm going to put 1k in its place. Because I think we're dragging the... There we go. All right. I need the pin out for this. This is a BTA 08. BTA 08 datasheet. All right, A1 and gate. Okay, so A1 and gate are the same. So gate and A1 and A2. Okay, I want to take this power from there. So I want to bring power into A1 and then take that to the gate, which is here. So this is gate. Okay. Right, so I want to bring power into A1 and then take power from there. I need a resistor. Oh, I can use, can I? Maybe? I have some heat traces that would be fine as resistance. Heat traces that would make some pretty fine resistance. But can I hook them up? Maybe? Maybe not? Think through this. Okay, the other thing I want to do is I want to pull voltage out of here. Is that pre or post rectified? That's pre. I guess I could put a pin there and attach to that. And then I could put a pin there and attach to that. And that would give me the 8 volts, or hi, Michael. I'm all right. How are you doing? Just thinking here how I want to do this. So if I only have 8 volts, then I should be able to put. How do I do the resistance? Right, so I am going to go in here, right? And I'm going to add power. So I can take power. Almost need something that's going to twin. I used to have something like that. Man, I'm making a bigger mess, and I only had one drink. I used to have a set of jumpers that split the leads. What'd I do with those? What did I do with my lead splitting jumpers? It's not those. I could be wrong. Do I have room for other jumpers in here? Not really. What's this? Trash. Melted trash. I have these over here for a reason. Ooh, I am yawning now. I am officially tired. Lead them astray. Anu up with the jokes. That is what? 5 jokes tonight. Used to have a twin. 6 jokes. How do I want to do this? I am thinking pretty hard about it. Oh! Oh, I know how I can do this. I have an idea. I can use this. I can. Yes, I can. So if I... Yep. And I put this to here. That gives me the power for that. Yes. And then if I... No. Boy, I'm really going to have to watch my... I'm really going to have to add some serious resistance to this to make it okay. This should be enough resistance to make it a milliamp. Setup. This should be enough resistance for that, but it's really janky. So I'm trying to think of how else I can do it. For starters, I need to plug this in. So I need a jumper to that. These are all male to female jumpers. Right? And I kind of need a male to male jumper. This is female to female. So maybe if I use some of these pins. Maybe. Let's try it. Where's my snippers? You know what? Pliers work too. Do. Okay. And I actually want this to be slightly more... And I dropped it. Yep, that's not coming back. Always work over the bench. Okay. And then I want this. To move just slightly to make it engage more positively on both sides. All right, that's pretty good. And then I can take this over to here. Right? Yep. I think that worked. God, these breadboard connections are just garbage. Okay, now I'm not really a fan of these other connectors, but we're going to use them. So I need to go take positive, and I'm going to go to there. And then the other one is going to go to here, and then to this, somehow. Maybe I'll see if I can, This is not the prettiest thing I've ever done. Do I have a black? What's that? Oh, it's a tech. Brown will work. Alright. This goes back to neutral. And then I have this. Neutral's white. And there. And somehow I need to isolate this in a way that's insulated in order to do this safely. This is not my best work, making connections. Oh, this is going to be so bad. Ugh. If I had another jumper, that would be one thing. You know, I have this here insulated clamp. I don't think that's doing it justice. Okay. Nope, not even a little bit. God, this is not doing well. What am I doing? This is just not... Just straight up not great. Watch, this is going to blow up on me. And then it's going to take out my phone, and then I'll be really up the crick. Because that seems to be what happens when stuff blows up on me. Alright. Oi, okay. Let me walk through this now then yet. I have 110 volts going to the board through a shady extension, which we're going to hope is making connection. That's going to the zero cross detection. That's feeding back into the digital circuit. And then I have another side that's going feeding the IGBT on A1. A resistor going over to, and this should be a 1000 ohm resistor. Brown, red, and black. Or is that? No, that's brown, black, and red. Yep. So 1000 ohm resistor going over to the gate side. Yep. And then A2 is going to the load. The load, which I know is a very high resistance. Coming back. And we have a 1 amp. Right? And I feel like 1 amp is actually more than these wires can take. But we'll see. Okay. I want to read... Oh, God. No, I cannot use the Tektronix on that. I need a battery scope for that part. So I can use the Tektronix on this part. I have to use my Varus, which is a battery scope, on the high voltage. Because a battery scope is not grounded to ground, and as such, if it's not grounded to ground, then if you hook something up backwards, you're not shorting it straight to ground. All right. And this part, okay. I will need to adjust the trace. This goes over there. Okay, so I will need to adjust the trace, but this should allow me to hook up. Let's see. Neutral should be this side. Yes. Oh, shit, that's fucking touching. That cannot happen. And then if I go with trace 1, that should be this side. Okay. And I need to adjust since I'm using that. Now if I use my Tektronix, I want to read with my Tektronix, I want to read my switching frequency right here. And I'm going to give it a ground. I'm going to give it a ground lead. I need a ground lead. Let's just make it a blue. I don't care. All right. That way the Tektronix is just doing low voltage stuff, which it's good at doing. Of course it's not plugged in. Good riddance. Oh, wait. The lights are on. Oh, it just takes a while to boot up. Sorry, my bad. While I'm doing that, I'm going to go through... While that's booting up, I'm going to go through traces, trace 2, take that off, back, trace 3, take that off, back, trace 1. We're going to take that up to 400 volts, back, 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 back. Bring this up to relative 0 there. Okay. Yep, that should fill that up. And that should tell us whether we're actually getting a switching signal. What is the end goal for this project? Well, for this exact... For this small portion, this is only one portion anew. This is only one small portion of a much larger project that I'm working on, which is a catalyst reaction turbine generator. But this specifically, I'm trying to make a driver to control a boiler, essentially, a chemistry boiler. That pot right there, you can barely see it, is an electric, essentially an electric boiler. Like a small scale. It comes out of a coffee maker, believe it or not, a Bunn coffee maker. Oh, okay, here we go. Okay, volts, I want 2 volts should be all right. Okay, let's see what happens when I turn this on. Oh, I really shouldn't get much. All right, I got yellow on 1X. Oh, yellow is on 50 volts. 5 volts per division. Oh, I don't want 5 volts per division. Put this position. I don't want to display that. Why am I getting so much noise? Probe is 1X. I feel like that's way too much. 2 milliseconds. My time Volts per division. Seconds. Let me check something else. Let me check. I have to tune up my Tektronix to make sure it's actually reading correctly. Oh dear, it is not. That's fine. And then I don't think that needs trigger level. Where's my trigger? Oh, trigger's on channel 1. Source. Channel 1. There we go. Bing. Okay, I don't think it needs to be that fast, but it is now set up with the right amplitude. Okay. Oh, this makes me nervous a little bit. All right, I've got a switching pulse on. Yep, I have a switching pulse going to the opto isolator, but I have no. Do I have this set up correctly? It looks like I don't have any. Voltage going to. Really? Is that just because it's not turning the triac on? Alright, I'm going to turn this back off, which should make that go to 0. I'm going to disconnect that so that I'm not potentially shorting things out. Wait a second. So many O's. Cool. How often do you go live? And do you have a set schedule? Well, Anu, with everything that has been happening with the computer blowing up and all the rest of life happening, it's kind of really taken a complete dump on my schedule. I like to go live at least once a week. I usually announce it through Facebook when I'm going live. I am on Facebook, The Renaissance Builder on Facebook. You can look me up. So I usually announce it through Facebook when I'm going live, just because it's more convenient that way. I do know that I need to create a schedule, and the live streams could be more set, but with everything going on in life right now, I have no way of editing and making videos right now, because the computer took a dump. And so with everything else going on, I kind of just play it by ear and am trying to do the things that I can do. So I'm literally live streaming from a cell phone. It's garbage, but whatever. So honestly, this is just the Renaissance building or Renaissance builder trying to make the best of the conditions that he's given. We're making lemonade out of the lemons of life right now, is what it amounts to. But honestly, it seems to be Mondays is fairly consistent that I can go live on Mondays, um, for the most part. But I don't want to make promises because, shit happens. Um, yeah, I know that's probably not the answer you're looking for, but that's what we got. All right. I'm going to move this over. All right, yep. We are simply not turning the opto isolator on. So I have good sine wave, but it's not getting through the IGBT. What does my gate look like? Oh, interesting. It's letting the gate go completely. So why isn't it turning on? I've got power to the gate, which honestly really probably shouldn't be. Oh, I'm going to have to rethink this a little bit. Looks good, no worries. It's how it goes. I thank you for for that. And I hope that, I genuinely hope that many others can feel the same way, can be just as generous. But realistically, in the wide world of YouTubes, you don't really get a whole lot unless you got great productivity. And this live stream is long as shit. It's fucking 2 hours. Holy hell. Nobody's watching the whole thing. This is gonna blow my numbers way. I don't care. I have it going to gate. So I have power going to gate. I have power going to A1. I have no power coming out of A2. Let's see what happens if I turn that around. Maybe I need to take power to A2. And then, yep, take the power to A2. And then come out of A2. Maybe that's what needs to happen. I think this just might be working. Could there be a blockage somewhere? Some sort of interference, maybe, with the circuit? Actually, I think I just figured out what happened. Let's see. It's changing! Ah! It's working! Holy smokes. Yep, look at that shit. Alright, it definitely needs refining in the wires. Alright. Electrically speaking, blockages are resistances, and in a mess like this, we have a ton of resistances happening just because our connections on the breadboard are frankly garbage relative to electronics. Alright, I'm going to show you. I'm going to pick the phone up, and I'm going to show you what I'm looking at here. Oh yeah, my voltages just went kind of haywire. Alright, I'm going to pick the phone up, and I'm going to show you what I'm looking at here. This is going to be a little awkward. Sorry for the Okay. This is what I'm looking at. So, this is my 110 volt. This is the this is the control voltage. So this is the pulse width going to the opto-isolator, and this is my 110 volt signal. When I turn this here potentiometer, right there, then you're going to see this signal change, and you're going to see this respond. So I'm going to turn the potentiometer, and you're going to see what I'm seeing. See how that pattern is changing? And then it gets a bit dirty, but then it goes away. Yeah, so I definitely need filtration for sure. In fact, let me hook the load up and see what it does. All right. Sorry for that camera shake. All right, I'm going to turn the power back off, and I'm going to hook the load up and see what the load does. See what it does loaded. So part of the dirtiness of the signal that you see is because we're unloaded. We're wide open. And oftentimes the load is required. A load helps balance reflective frequencies. Here we go. All right. Oh, that's so beautiful. That is exactly it. Oh, it's not cutting down as much. Turn it off. Back on. All right, it definitely needs refinement, but it does work. All right, let me show you. So this is with the load connected. All right. So load connected. You can see the pattern. This one, the control pattern down here is still the same. The measurement keeps fluctuating on me. That's why that's doing that. All right, so when I turn this, now you will see the pattern go to a full sine wave. That's 100%. And then we start cutting down. And it's not cutting down as far. We're not turning off quite as well. But that's just fine-tuning the circuit is really what it amounts to. Yeah. Whoop. Screensaver. Yep. There it is. It works. Ha-ha! All right. We have just accomplished exactly what the live streams are completely supposed to be for. That's exactly why I do these live streams, because we now know that this works. I need to refine it for sure. There's, some chokes, some snubber circuits that need to be involved, kind of stuff, but this is refined enough to know that the principle works. So from here, I can start adding on other features. I can figure out how to program, believe it or not, this is something that kind of floors me as soon as I can figure out how to get it to work. The motor controller portion, what the Arduino Nano is doing, is going to go on this chip. It's just it's an 8-pin, or 80 tiny, it's called an 80 tiny 85. This is actually a programmable chip, believe it or not. It's crazy. But the idea being, I'm going to program this little tiny chip to take over the function of what the Arduino Nano is doing now. And then I'm going to use the Arduino Nano to run the rest of the function. In other words, it's going to be responsible for a display screen. It's going to be responsible for temperature sensors, water level indication, or fluid level indication in this case, as well as read the potentiometer, and anything else I decide to put in there. Maybe like some safeties or something. So the Arduino Nano is going to take over all those other functions. Particularly the display screen will be the more interesting part of that. I actually have two different display screens here. I'll probably be using this one just because I need to get rid of it. So, you know, a display screen. And, oh, I'm going to have to figure out a new box because my old plan wasn't quite as soft to make a box for that boiler. But yeah, this works. We're good. After over 2 hours on a live stream, we have a fully functioning dimmer control circuit. Now what this allows me to do, this allows me, and this is the whole point, this is the whole micro, or what do I call this? What should I call this? It's a sub-project, right? So I have the main project, and then this is a sub-project of the main project. I don't know, project that. Anyways, the whole reason I went through this is because I can now allow a computer to, and this is something I haven't seen, the really fancy chemistry sets that you can get will allow you to fine-tune a temperature and hold to a temperature. But I haven't seen anything that can do that for under like $1,000 kind of stuff. So this, we are basically making a homemade chemistry boiler that will allow me to set a temperature, and then the computer controller will do whatever it needs to do to maintain that temperature, meaning it can lower the power and raise the power of the heater element to maintain a specific temperature. That's the whole point of this little grouping here. This little project, actually this is like third tier project, because the second tier project is we're purifying hydrogen peroxide. And it's all part of that engine, but we're purifying hydrogen peroxide, so that boiler is going to be a vacuum chamber that is heated to a specific temperature to allow us to vacuum purify hydrogen peroxide, kind of thing. So, yeah, this is an accomplishment. Thank you, Anu, specifically for watching the whole time. I really appreciate it. And, yeah, till next time, I guess. I'm gonna cut the live stream out. We have had success. We're gonna quit it now. You know, quit while you're ahead. And I'm going to, off camera, I'm going to work on condensing all this into what it needs to be. I need to fine tune the zero cross detector and a couple other things that need to happen, and I can put this onto some project boards like this. So I can actually put all this stuff onto some project boards so that it's not janky, messed up stuff, and go from there. Yeah, this is fantastic work. 100%. Beautiful. Absolutely beautiful. All right, thank you very much. Take care, Anu. You get some rest as well. I hope you have a great day, whatever comes into your future. And everybody else that could be watching into the future, I hope you have a great day as well. See you on the next one.